Hey, for everyone on the call, appreciate you joining. We are going to get started in just probably about 2 or 3 minutes here. We want to give folks a couple minutes to log in. So just hang tight and we will get started shortly. Hey everyone, good morning. We are going to get started in just about 1 minute here. Thanks to everyone who's been able to jump on so far. We'll get started really shortly here. Thanks. All right, good morning everyone. Thanks so much for joining. We're going to go ahead and get started now. We've got a couple of folks on the line that you're going to hear from today, and we're going to be covering anything and everything related to GitHub Advanced Security. And at this point, I'm going to, I want to say two things. One, I think everyone should probably be in listen-only mode, but the second thing I wanted to say is you should have access to the chat window. We would love to hear any questions, comments, anything that you might have that you want to contribute. But we will be doing a short Q&A at the end. So if you have questions as we're going, you can chat them in. You can chat them directly to me. My name's Tim Labarge. I'm the VP Marketing at CEI. So you can chat them in directly to me. You can chat them to the whole audience. But either way, we'll get to those questions at the end of the session. So at this time, I am going to hand it over to Chris Wootten. Chris, why don't you get started here and take folks through what we're going to discuss today.
Well, thank you very much, Tim. And if you could advance to the next slide. Good afternoon to everyone in Western Europe, and good morning to everyone in North America. Welcome to our webinar today that we're hosting with GitHub to talk about application security and how to protect your apps with advanced security. Let's kick off today's session with two slides to kind of stage where we are in the InfoSec world. This comes from the European Union Agency for Cybersecurity. They do forecasting on what threats they think the world will be facing with as much vision as they can put on the future. A lot of this stuff is not surprising, but I would like to call out two things that are pretty important here. The first one is supply chain compromise of software dependencies. We've all seen these infographics before, but what you won't see in this one is things about ransomware, because what we learned from the pandemic, that there's an opportunity in the hacker community to not just bring down an enterprise for financial gain, which is still part of what they're going to do, But the pandemic showed the fragility of the supply chains around the world. So it's not just bringing down an enterprise, a financial gain, but damaging an entire ecosystem within the supply chain for greater gain and greater financial gain. The second thing I'd like to call is on the rise of digital surveillance. We've heard about it, we think a lot about it in Asia and so forth, but this is really relevant to what's going on in today's world. And Tim, could you please go to the next slide? Now, please bear with me. I'm actually going to read from a script because I really, really want to be accurate in reporting what I'm about to say. In January, Frontline and PBS aired a two-part special on Pegasus, the mobile device spyware developed by NSO, an Israeli company. Now, NSO claims Pegasus is sold only to governments, but they have not been transparent in who their customers are and what it's used for. 18 months ago, the Guardian Media Group in London came into possession of 50,000 mobile numbers that were leaked from NSO. The Guardian formed an alliance with the Washington Post, Le Monde in Paris, Le Mercure in Tel Aviv, News India, Radio France, and of course PBS and Frontline, plus 75 independent journalists around the world. They distributed the leaked phone numbers to the collaboration team to cross-reference the phone numbers. Over 1,000 numbers were identified as belonging to journalists, activists, politicians, including the head of state, the president of France. They then contacted the known owners and requested the mobile devices for forensics. The team retrieved 60 phones and found 39 had been infected with Pegasus and were able to determine how they were infected. Most were through Apple Music when the device owner played a song. 2 of the infected phones belonged to the wife and the fiance of Jamal Khashoggi, the assassinated Washington Post journalist. Subsequent from this reporting, Apple is in a major lawsuit with NSO Corporation right now. If you go to their website, you'll see they've done a major reorganization. Their CEO has resigned, and there's a 15-page PDF on how they're trying to claim some level of transparency on what they're doing. So these threats are real and they're happening today. And the next slide. So once again, welcome everyone to our webinar today. Gentlemen, please turn your cameras on so we can see who everyone is. Our agenda today, we're going to run through a couple things. We're going to talk about application development and security by design and how that's built into the whole SDLC process. GitHub's AppSec proposition was part of this. We're going to do some demo stuff on some really cool things. We're going to really showcase 3 things. There'll be a short demo where we think you'll be inspired for it, do some QA, and then talk about a next step offering we have that's free. That's a workshop we're going to offer attendees to help do some demos, to do some relevant things based on your individual enterprise scenarios. And we'll talk a little bit about that in a moment. So my name is Chris Wootten. I'm the GitHub Alliance Director at CEI, celebrating my 13th year. My short version of my bio is I'm in my 4th decade in the application development world. Love it, process, technology, and the whole bit, and have had a great career doing this stuff. I'm joined by my teammate, Siva Kumar. Siva's degree in electronics and communication engineering, rounded out with an MBA. He's an active blogger on the conference speaker and cloud technology circuit, and really loves to speak about best practices in software engineering. His passion for the art and science of building software has served him well. For the last 13 years at CEI, I was the principal architect, and he's the director of our DevOps practice. Now, Siva and his wife live in Orlando, and I'm going to quote him here. He is the proud parents of 2 young princesses, and we're kind of figuring out that he's calling them princesses because he's written a lot of mobile solutions for Disney, and I'm wondering if there's a correlation there.
Hello, everyone.
Yeah. And we're delighted to have Niro Rajadurai. Niro is degreed both in computer science, electrical and electronics engineering from Melbourne University. He brings over 20 years of experience in the design and development of safety critical and fault tolerant systems. In recent years, he has collaborated in the development of pioneering innovations in the field of DevOps and app security. These include technologies such as application security testing, change-based testing, code fuzzing, and variant analysis for the hunting of 0 days in enterprise software. He's an active blogger, has published over a dozen magazine articles, has had multiple conference speaking engagements. And prior to GitHub, Niro led growth at Semel, the company behind CodeQL, the semantic code analysis engine, which powers GitHub's advanced security code scanning capability. GitHub acquired Semel in September 2019, where he works today. as the Senior Global Director of Advanced Security and Sales, and he resides in the UK with his wife. Now, there's an interesting fact I found out about Niro, and I wanted to share this. And it's very interesting. He is a contributor to the Parkes Radio Telescope project in Australia via the Anomalous Pulsars Detection Program. Niro, I have no idea what that is, but I have one question. Is that where we're keeping the aliens? Because it turns out they're not in Area 51.
Well, it's a really fine question because in the early days when anomalous X-ray pulsars were detected, they believed it was radio signals from like alien civilizations until they further investigated it. So yeah, it's a very, very interesting topic that we can get into.
Okay. So you're saying that's not true and I don't need to wear a tinfoil hat during an eclipse? I'm okay with that. All right. And Niro's going to lead us off today. And thank you very much for joining us today.
Thank you. Thank you for having me.
Yeah. All right. Niro, I'm going to hand the presentation over to you and you can take us through the next portion if that works for you.
Thank you. Excellent. So thank you all for the opportunity to speak here. I thought it might be interesting in our discussion of DevSecOps to maybe like go through a little bit of an analogy. So in this painting, we have a surgery that's happening in the 1800s, and we have a person in the center of this picture with the bow tie, and his name is Joseph Lister. Joseph Lister was an English surgeon and professor of surgery who introduced antiseptic surgical techniques. He's sometimes known as the father of modern surgery because his groundbreaking work helped overcome one of the major obstacles in successful surgery, the control of infections. He successfully introduced carbolic acid to sterilize surgical instruments and to clean wounds, and among many other surgical techniques that he developed. If you look at the picture here, there are two men in the front of the screen. On the left-hand side, this gentleman is applying anesthetic to the patient. And on the right-hand side, the gentleman is spraying an antiseptic spray that helped reduce the mortality rate for the patients undergoing the surgery. What's interesting here is that both of these foundational concepts in modern surgery had very different adoption paths when they were introduced. So what can we learn from this? So if we take a look here, anesthetics were first discovered in 1846. Within a year, were used worldwide, and within 7 years, they were ubiquitous in standard operation procedures. Antiseptics, on the other hand, had a very different journey into adoption. Until the acceptance of germ theory in the 1860s, surgeons did not take any precaution to protect open wounds from infection. They didn't wash their hands before operating, sterilize their equipment, or clean their operating table. With the introduction of antiseptics, as always with new ideas, there was some opposition. Many surgeons claimed that Lister's antiseptic methods slowed down things at a time when speed was still essential because of blood loss. Lister could be very critical of other surgeons or other people's work. Therefore, these surgeons were reluctant to accept his ideas. And many surgeons lived with the fact that lots of patients would die. For them, it was an acceptable part of surgery. Despite this opposition, it was soon obvious that Lister's methods were a success. In just 3 years, he reduced the death rate among his patients from 46% to 15%. Even still, it took a further 12 years before it became routine for basic procedures to have antiseptics, and still a further 10 years beyond that before it was used in cardiac surgery. It's pretty amazing. And so the argument that we're trying to make here actually is that DevOps is kind of like anesthesia. It makes the lives of developers better. Everyone wants to ship software faster and not have bugs. And the really interesting thing is DevOps was adopted by choice. Everyone went down this path. Security, on the other hand, is like antiseptics. It's like spraying carbolic acid on the devs. Yes, it makes a difference, but it's not pleasant. Devs don't want it because if they feel like it slows them down. And so the spread of DevSecOps is actually pretty low in industry today. And what's interesting is as we start looking at some of the data science behind what's going on here, we here at GitHub did some research on a bunch of open source repositories, about roughly 70 million lines of code. And we plotted the behaviors inside this repository. So if we take a look here, you have this blue line, which is the lines of code. And as you would expect with any kind of popular open source repository, as time marches on, the volume of code in that repository continues to grow. If we take a look at the purple line here, the purple line is looking at commits that are mentioning vulnerabilities. So like, hey, I'm fixing this vulnerability. Are you aware about this vulnerability in the code, etc. And what we see here is that this kind of mention of vulnerabilities is pretty flat until about the middle of 2017. And then suddenly there's a huge uptick in the mention of these vulnerabilities. Cause a correlation, that's roughly around the time of the whole Equifax breach, and so the awareness that there was this kind of threat surface through the supply chain. What's really interesting though is we take a look at the red line. The red line is talking about the security threats that are being introduced into the release branch of these applications. And what you see here is that despite there being a growing awareness of security vulnerabilities in the code that's being maintained, the rate at which developers continue to introduce security threats remains unchanged. It still keeps going at the same rate, consistent with the lines of code. And this again comes back to the adoption of DevOps versus DevSecOps. And more interestingly, if you start looking at like the Verizon data breach reports and even the Gartner reports, they talk about the fact that roughly about 45 to 50% of data breaches today are caused by weaknesses in application security. Web attacks are now the #1 source of data breaches, but amazingly, less than 5% of data center security budgets are spent on app security. So hopefully you're starting to see a pattern around the antiseptics and anesthetics discussion and what's really going on in the security industry today. And so the thing that we want to start talking about is secure by design. How can we secure development end to end? And what is like GitHub trying to achieve here with our partners? And so what's probably interesting is to maybe talk about a concept that's at the DNA of why customers begin their journey with GitHub today, right? So both here at GitHub and at Microsoft, we've really been thinking through how the best software development teams work, whether these are teams within an open source community or teams at leading global enterprises. And we found that at the heart of modern development teams is a concept that we call developer velocity. Teams that have higher developer velocity can work autonomously and quickly, ship quality code safely, and bridge across organizational boundaries, even with large-scale teams. And if a company can achieve these workflows, it ultimately builds developer happiness as well as allows them to ship fantastic experiences for their customers. What we see is that organizations that work with such teams see results such as 100 times faster setup of development environments, 200 times more frequent code deployments, 7 times fewer failures, and the most interesting statistics for this conversation today is 8 times more likely to have integrated security. Ultimately, these elite software organizations have 4 to 5 times better revenue growth than others. And so, if we go to the next one. So we see a lot of our customers facing big challenges implementing DevSecOps, or they're at a stage where they kind of already went through that change, but the promised successes failed to materialize. And ultimately, from our customers, we hear 2 very consistent themes. One is enterprises want to accelerate software delivery to provide great experiences to their customers. And secondly, they have a number of things they want to improve as part of their DevSecOps implementation. And so, as part of that, here at GitHub, we believe the best way for enterprises to solve for accelerating velocity is to focus on their developer experience. By creating an experience that empowers your developers to do their best work at work, you're naturally increasing your ability to deliver more innovative and secure software faster. And so fundamentally what we're saying is that AppSec shouldn't be a siloed activity occurring in some other ecosystem in some other tool. It should be built into the developer lifecycle like we show here. And actually, if we click here, if we look here, I mean, the capability that we have at GitHub that's designed to help with this is GitHub Advanced Security. And there are probably 4 key themes that are important here, right? So one is it needs to be native. It needs to be deeply integrated to where developers like begin their work and ship their code. We shouldn't be sending developers, through multiple different places. Like I need to look at this tool to understand the state of like the code that I'm writing, this tool to understand the state of the supply chain coming in. It should all be in one place. It should be really easy to automate and deploy. We understand really well with developers every time we make a change, every time we ask them to do something manual when they make a change, this really slows down their productivity. It should be really important to understand the security posture of all of their code, and they should be able to do it where they're building their code, again, not going into another place. We should be supporting trust by design, so building tools integrated into the workflow that allow us to do static code analysis, analyze the supply chain, prevent credential leakages, integrating the security research that GitHub is doing into customers' workflows. So when we hear about a 0-day, we might go and build queries to go and look for particular variants of those problems, like log4j is a great example, and then rolling that out to our customers very quickly so they can leverage the research that we're doing, and making it an extensible platform so you're not kind of like tied to like this little closed box here. It is a platform in which you have out-of-the-box experiences that you can use from GitHub, but you can bring in other tools as well and integrate into this native developer experience. And the key to all of this is, like, if you remember the pictures I showed you before, fundamentally in the industry today, no one's really fixing stuff, right? Like, we still see this huge weakness in application security. So the key here is, like, how do we help developers fix stuff? And what we're talking about is empowering them to fix these vulnerabilities at a place where they naturally collaborate and make decisions on merging software together, such as in the pull request or when they're pushing code into the server. Providing automated fixes where there are problems in the supply chain, making suggestions to like automatically remediate those, really keeping the language simple, keeping the jargon at a level that the developers understand, and enabling the developers to operate freely. So we operate on a concept of trust but verify. So getting out of the way of letting developers ship software, but having the tools in place to understand what exactly has happened so we can apply audits as we need to. And then most importantly, GitHub is a place where 100 million developers come together and participate, and leveraging the skill of that community to help drive AppSec forwards. I think these are really like key tenets on making this successful. And so we bring like 3 key pieces here. So helping secure open source software. So, GitHub is a certified naming authority. So what this means is that I think over 95% of the world's open source software is developed on github.com today. So when a researcher or when a maintainer identifies a vulnerability in the code that they're building in this open source package, or analyzing this open source package, we want to make it super easy for them to notify the maintainer, hey, I've detected a vulnerability. Make it really easy to have a CVE created if that's required, and then helping the maintainer remediate that and pushing that update out. And so when that kind of workflow takes place, that automatically gets pushed into our security advisory database, which is open, which means that anyone can go and grab that information, but that technology or that database is directly integrated into our supply chain tools. So immediately we would tell you, hey, this dependency that you're using, someone just published a CVE, you should go and bump from version X to version Y to remove that issue. Vulnerability management, so automated code scanning, so looking for vulnerable patterns inside your source code, looking for secrets. Credential leakages is actually the #1 reason for data breaches now in web applications. I think 80% of data breaches are caused by in web applications is caused by leaked credentials. It's also something that we see a lot of visibility at boards within a lot of our customers. We have this huge vulnerability database of all of these known open source vulnerabilities, and automated security updates to help developers remediate and remove that vulnerable component from the supply chain. And then we have CodeQL, which, as Chris mentioned before, is a technology that we brought across from SEML. CodeQL treats your source code as data. Think of a relational database. In a relational database, you can write a SQL query to look for patterns in the data that exist there. In a very similar way, we have a language called QL that lets you describe, complex semantic patterns and describe control flow parts, data flow parts, and even do taint tracking as well. And using this language, we can describe queries to look for all of the standard kind of like OWASP type checklists, but also build customized checks that might be proprietary to your organization and enforce these properties statically versus like through dynamic testing, like pen testing or something like that. And it's completely open. So we have an extensive set of community researchers, security researchers that contribute to that. So with that, I will hand over to Siva to take over the demo.
All right, thanks, Niro. Appreciate you running us through that, and not only covering the importance of advanced security, but really, you know, giving us an understanding of what the benefits are across the organization, right? So at this time, I am going to hand this over to Siva, and Siva, you should be able to share your screen now.
Yeah, hopefully you can see my screen now.
Yeah,
thanks, Niro. Thanks, Niro, for the great explanation of GitHub Advanced Security and what are the objectives of the GitHub Advanced Security into the organization, right? So today I'm going to show the demo, what are the different GitHub Advanced Security components and how the GitHub Advanced Security components natively integrated into your developer workflow so that you can fix the vulnerabilities in minutes, not by months or years, right? And also we are going to show you a different part of the demo, how you can secure the supply chain and how you can secure the vulnerabilities in your app code base and how you can identify the secrets that are leaked and how you can enable the push protection, those kind of stuff. I'm going to walk you through in detail there. So let's start with the depend.bot. So we have set up an environment, right? We have our code base in the GitHub repo. But it is very important to ensure that all of the code we are developing is secure from vulnerabilities. That includes our dependencies, right? So this is where the depend.bot comes in. So the depend.bot, it automatically updates vulnerable and out of date dependencies for you. So how it's going to work? So whenever the GitHub is notified through the various channels, there are a different channels available, like a national vulnerability database and GitHub advisories or other channels there. So whenever there is a vulnerable in the dependency that is got notified to the GitHub, the depend.bot that starts working. So the depend.bot is going to send you the pull request to update your dependencies to the first known version that does not include the vulnerability. For example, here in the screenshot, it says the ProtonJ library is going to update from 0.12 to 0.30 because that is the first version that is non-vulnerable, right? So in this way, it's going to increase the developer speed because whenever the vulnerability is reported, we usually identify the vulnerability from the vulnerability database, but the actual time it took to fix the vulnerabilities, that is the mean time to remediate the vulnerability, right? So the mean time to remediate the vulnerability is a more slow process in the normal system. But since the depend.bot, it just automatically create the pull request for you, you are able to see the pull request in your GitHub on your day-to-day activity and see okay, this vulnerability is introduced in this version and the pull request is created already for you so that you can quickly review that and then merge the code into merge the pull request into your code. Okay, so let me quickly show this slide. So this is the industrial norm here. So the mean time to remediate, the industry norm is 180 plus days. What does that mean is whenever they have identified the vulnerabilities and from the time from the vulnerabilities disclosure to patching a project, that is 180 plus days in the industry norm. But the GitHub is reducing that mean time to remediate to 40 days. This is little bit old data. Now they are trying to close as much as possible. So nowadays the mean time to remediate is further close less than the 40 days here. So that's how the depend.bot is trying to get you into that vulnerability dependencies management automatically for you. So let me quickly show the demo to you. So here we need to configure the depend.bot, right? So I have this repository here, and there is a YAML file we have to configure. And in the configuration, it's like pretty simple. There is no like a complex configuration you have to do. Here I'm saying like, okay, I need to scan the dependencies, and my package ecosystem is npm dependencies or Python packages or like any Go modules or NuGet packages. You can specify like what package ecosystem you need to scan and which directory the particular source code or like the particular package.json or like the dependencies are there, right? Then you can specify like, okay, how often I have to schedule this depending about version updates. Here I have mentioned like the daily, so it's going to scan the advisory database daily, and if there is like any vulnerabilities reported, it just like create pull request there, right? So you can see like I have enabled this for npm and the Python packages. If you go to the pull request here, it just like bumped the versions from like Flask from 1.1.2 to 2.2.3, like that. Like you can see that the npm packages as well, right? And it's nicely labeled. You can see like all the PR are labeled as like dependencies, and which language packages are here. Those are also like labeled here, right? So since this is like integrated with the pull request workflow, it automatically runs your CI/CD test and make sure nothing is broken, and you just like pass the test as well or the checks as well for you, right? So you can go here and everything like is successfully run, successfully checked. You can like do some quick test and then merge this pull request to your code. If something is broken, then probably you may need to adjust the code base and then like merge the code. So basically, like by enabling this depend-abort, that's making like your developer experience more easier, and everything is like natively integrated to you so that you can easily manage these vulnerability dependencies here. Okay, so now we see like how we can fix the vulnerabilities in the dependencies, right? But what about the vulnerabilities in our actual code? So in the app code base, that's where like the code scanning coming in. So the code scanning is powered by the CodeQL engine, where Niro and Chris talked about. It's going to find and fix vulnerabilities as you code, right? So whenever like the code is merged in, it's going to do the quick scan, like the automated CodeQL scan, using your source, right? So it's going to like identify like the known security vulnerabilities. For example, here like they are doing the server side URL redirect, so it knows like, okay, this is the pattern for this particular vulnerability here, right? So how we can identify that vulnerability in your app code base and notify you, so that we can identify like, okay, these are the common problems that's going to expose our application, so that like we can fix that or do some remediations around that, right? For example, we are doing some SQL injection, or we are not doing input validation before accepting into the database. There are like a lot of known vulnerabilities, right? A lot of patterns where the vulnerabilities can happen. So that's where like the code scanning comes in. And the one important thing is like this is powered by the community of top security experts. So all these the patterns, you can like have everything there. There is a database already available. So your code base is going to run against the database and give you the result of your code scanning alerts. But if you want to do like on your custom, you have to add like some custom logic to identify like a certain things in your code. You can add like the custom logic as well. So that way, like you can create custom CodeQL queries that can run against that custom query and identify the patterns in your code, so that like it can trigger the code scanning alerts over there. And the last thing is like, as we see the depend-abort, this is like integrated with the developer workflow. So you are not like developing a product for an year, and after an year, when we are going for like a production, like, hey, these are the vulnerabilities we see, you have to fix it. That's going to take like another 2 or 3 months, right? But in this one, like whenever the pull request is happening, at the time, like the code scanning result will be identified, and it immediately notify like, okay, these are the places we have to fix, and these are the places like the vulnerabilities have been found. Then it just like not only like say, hey, this is the place you have to fix, it also gives like the recommendations, right? So these are the things like you have to do, and these are the steps how you can fix that. Those kind of recommendation, the code scanning alert that can give, so that like the developer, whenever like they are merging the pull request into the main code base or the release branches, they know like okay, they are confident enough to like say, okay, my code base is like vulnerable free, and my code base is like free of all these vulnerabilities, right? So everything is like measured into the pull request workflow itself. Let me quickly show the demo on that to you. So let's go back to the code security analysis. The setting the code scanning is also like pretty easy. It doesn't have like any complex configuration. You basically go to like the code scanning and go to the code QL analysis, uh, set up the default or like the advanced configuration here, right? So it's going to set up a YAML file that is like the GitHub Actions YAML file. So here you can see there are like a certain strategy or like a certain languages we are using, right? So in this one, we are initializing the code QL. So whenever like we are using the code QL action, we are specifying like which languages we are looking for, like the code vulnerabilities, right? So in this example, we are having like a C#, Go, Java, JavaScript, and Python, but there are like a more additional supported languages as well. You can specify like whatever the language your code base has, but there are like additional language you can mention if you are using that as like a mono repo kind of stuff. So the steps are like very simple. You need to initialize the code QL, and then like you use the auto build. The auto build is like identify what languages you are using, and then like automatically build your code. But if you're using like any custom build scripts, you can use the custom build scripts as well, because the code QL is going to run on like your compiled languages. So you need to build before running like performing the code QL analysis. Then you need to like run this code QL action analyze language and say like just perform the code QL analysis, right? What it's going to do is it just like create a code QL scanning alert. For example, here I'm going to the security tab and the code scanning alert. It identifies like all the vulnerabilities and categorize into like a critical, high, medium, or low. So it's just going to like report all the alerts here, right? So for example, here like there are some clear text logging of sensitive information that happened. So we can go and identify like, okay, what's the problem, and see the details. What are the recommendations that are like provided? We need to like encrypt or obfuscate before being logged, so that like we know what's going on over here, right? So this one is like it just identified the existing code, but what if I have introduced the new vulnerability in my like new commit, right? So let's say like as a developer, I'm writing like some queries that has like some vulnerabilities. So whenever like I created a pull request, the code QL action scanning that's going to like trigger, and you can see like I have added some eval JavaScript eval that's like the vulnerability stuff, right? So whenever like I created the pull request, the GitHub code scanning that automatically triggers, and it immediately added that as a comment or action in the pull request itself. So whoever is going to review, they can come and review like, okay, so this commit, I reviewed all the files changes, and the GitHub code scanning reported like this code is a vulnerability. So we can just like immediately, as a developer, they can go ahead and fix that, and they can see like more details, like what is the recommendation they have provided, and added like take the necessary recommendation into the code security, right? So this way, like we are protecting in the pull request workflow itself before your vulnerable code ending into that the release branches. So that's how like the code scanning that's going to help to find and fix vulnerabilities in your application code. The next component we are going to see is like a secret scanning, right? So previously we see like the fixing the vulnerability in the dependencies, fixing the vulnerabilities in the app code base. But there is like a Verizon data breach report that says like the leaked secret, that is like the #1 cause for like all the security things, right? Because it just like identify the leaked secret, and they just like misuse that the secret to get like acquire of the valuable resources like cloud environment or any other secrets there. So that's where like the secret scanning is very important component in the GitHub Advanced Security. So what the secret scanning is going to do is it identifies secret as early as possible, right? So find the secret whenever like it pushed to the GitHub, and even the GitHub recently introduced the push production. So it not only like after pushing the secret into the GitHub, it just like identify the secret in the commit itself, and it just like reject the push itself, right? So if you are trying to commit a secret in your GitHub, and if you are trying to push that commit, it just like GitHub API, it automatically detects like, okay, there is a secret identified in this commit. So it's just going to say like, okay, there is a secret identified, and what you want to do. Is it like a test secret, or is it something like you want to like block the secret, right? So you can like take the step there. If you want to block, it just like blocks the secret from the push production, so you know like what you want to do there. And there is a big community of secret scanning partners. So not only like a generic regex kind of format, there is a secret scanning partners that like are tied up with the GitHub itself. So in case like there is a secret leak in your organization, the GitHub is able to like identify and notify the secret scanning partners so that like they can take necessary action if the secrets are like identified, right? And also you can like define custom patterns. For example, in the enterprise, we have like some custom patterns we need to identify. For example, like I have a internal application that is like very crucial for my organization, and I am following like some custom pattern for that. Like for example, regex starting with like A, B, C, and I have like 8 digits, 16 digits number. So there are like certain custom patterns you can set so that like you can scan for the patterns that are internal to your organization across the repositories, right? Let me quickly show the demo on this secret scanning. So in this one, I don't have like the secret scanning enabled for this organization. Usually like when we are going to show the demo, they have like the leaked secrets already in their repositories, right? So when we are going for like enable the secret scanning alerts, we should be able to know like how many secrets that are already leaked in these repositories, right? So I have enabled the secret scanning, and we can enable the push production also, and we can add the custom patterns as I have already told, right? So once I enabled, you can see the secret scanning alerts. So there are like 11 secrets that is already like exposed. You can see like it includes Amazon key, Google API key. There are like different keys that is coming from the various partners. So you can specifically see like, okay, these are the keys that is like already exposed in my organization, right? Now, since we have like the push production enabled, let's see here. So I have added like a key here, the test key, which is the custom pattern. So the custom pattern, which we have enabled in the settings. The test pattern, and the test pattern has test underscore 8-digit number, right? So you can specify like the custom format here. So in this one, I have added like a test underscore, the 8-digit 1, 2, 3, 4, 5, 6, 7, 8, the 8-digit. So I have that commit. And since I have like enabled the push production, it should not be like accepting this secret, right? So let me see. So now you can see like I am trying to push the commit that has the secret, the custom pattern secret. It just like identified that the commit has the test pattern, and it's giving like some options here, right? So for example, if I'm clicking the link that mentioned, you can like override like it's used in test, or it's false positive, or I will fix it later, so that like it's not blocking scenario for your test secret. it just like notifies you like if there is any leaked secret over there. Then we need to like have the single pane of dashboard that has like a security center and compliance. So you can like go to the security center and look for like, okay, what are the repositories and what are like the risk are like identified in the repositories. How many alerts in the code scanning, how many alerts for like a depender bot, is there like any leaked secret detected in your secret scanning and all. So you can have like the full security center, the single pane of dashboard for your entire organization. So you can see like it's just giving all the details here, like how many repositories affected and how many scanning alerts, those kind of things. And not only for like the organization, they have recently introduced for like the enterprise as well. So you can go ahead for your enterprise and see like, okay, what are the depender bot alert, the code scanning alert, and secret scanning alerts for all your organization, right? Because the one enterprise have like multiple organizations. So here is a place like you can manage and bring the complaints across your organizations over there. And finally, so it's not only like the native integration, the GitHub Advanced Security. As like Niro mentioned, it should be like the extensible platform so that like you can bring your favorite tool to your GitHub Advanced Security components, so that like you are bringing the security measures closer to the developer where they are developing, where they are using it like a daily life, right? So there are like a third-party security tool integration you can do with the GitHub Actions and GitHub Advanced Security. There are like multiple actions available in the marketplace. You can also create your own action to customize the code scanning alert. For example, like I'm developing an infrastructure as code. I need to do like some static analysis for the Terraform or for some infrastructure as code there. And I got to do some scanning, like cloud security scanning or like infrastructure as code scanning. So you can bring those actions, and whatever the reportings find by these actions also included in the GitHub Advanced Security Center, so that like you can bring your third-party actions as well to get into this security center there. Yeah, so that's the wrap for this demo. We have like explained in detail. If you want to like have more things, we can definitely look at that. Over to you, Tim.
All right, thanks so much, Siva, for walking us through that. I think it's great to see kind of the practical application. Hey, here's, we're talking about all this stuff, but hey, here's how it actually works. So at this time, Niro got a couple, I think a couple additional slides that we were hoping you could step us through here. I've got control of the screen. It's just 2 slides. So if you want to, if you're able to just walk us through this, this flow chart here, and then I think one more slide, that would be great. I think you're muted still here.
Classic. I haven't learned anything since COVID. Siva, thank you for that great demo. I think that was really good to kind of walk everyone on the call through the capabilities of advanced security. I think the point that we wanted to make through on this slide is, what you can see in this picture is what your typical DevOps workflow would look like today. And in the red elements here are how GitHub Advanced Security is going to supplement those processes. So whether it's, on defining like platform security and policies, to doing like code review or assisting in the code review process to tell you about vulnerabilities that you're introducing, to enforcing policies around like SAST, SCA, and secret scanning. And most importantly, bringing this into a workflow where you can collaborate in exactly the way that you already do today for all of the other software that you're building in your business. So that's really the key message we want you to take away, is this is additive to your experience, but it's still in a natural way that you're used to working with GitHub. It's not creating a brand new estate where you need to go and consume this information. Please, next slide, please. Thank you. So probably the things that I want you all to kind of take away from the conversation that we've had today is really there are 3 main reasons why GitHub I think is super valuable and could be very interesting for your organizations. First of all, GitHub is a platform that's developer loved. It is the world's most popular developer tools platform. There are over 100 million users on the platform. So if you're an organization thinking about how to implement DevSecOps, as we saw before, having a functional DevOps that's well loved by developers is the foundation for that. And then integrating security naturally into that workflow is really the next step in making DevSecOps successful. So that, I think, is one of the most important things. The second one is GitHub is the home to the vast majority of the world's open source software. As I said before, about 95% of the world's open source software is built on github.com today. And so really bridging that gap between the open source packages that your organization is consuming and the applications that you're building is really, really valuable in maintaining developer velocity and creating a workflow that can let maintainers on those open source software projects share new issues, new vulnerabilities, just like an engineer or a developer inside your organization would as well, I think is really critical to helping solve like the supply chain problem and in particular the vulnerabilities in the supply chain. In fact, an interesting data point for all of you to leave you with is that at GitHub, we've issued more CVEs for open source software projects than all of the other security vendors combined in 2022. So GitHub is really the home of open source software, both for the development of it and the securing of it as well. And then finally, the big challenge in the industry, if you remember the graph I showed you at the start of the presentation, is that developers are struggling to fix vulnerabilities today. So we're really focused on a results-driven approach to application security, which is around remediation, like fixing security issues. And again, a really great data point across GitHub, more than 24 million vulnerabilities were remediated in 2022. So we're really demonstrating a huge impact in how developers are actually fixing vulnerabilities in their code. And so I think these 3 points are really important takeaways that I'd like you to have from this presentation as you think about what your DevSecOps journey would look like. Thank you.
Thanks so much, Niro. Really appreciate you taking the time to join and having you here. It was so much, it was extremely valuable to have your perspective on everything here. So we appreciate it. All right, Chris, we are back over to you, man. Why don't you take us through the last couple of things we got here?
Yeah, that's great. Thank you, Niro and Siva, for sharing today. And one of the takeaways I have in this, one of the things I like is when we talk about advanced security and some of the key points on using it, that it's built into the workflow, that for the developer experience, we want to make it as frictionless as possible. And we want to drive it with automation. And why is that important? Because when we talk about true DevOps and what it means to the business and increasing velocity, time, speed to market, high quality code, and all those things, is enterprises hire highly skilled, highly talented, highly passionate people to build software for them. And everything we can do to tie into that passion by providing automation, for giving them that workflow that's very conducive to that passion, the higher the productivity. Then those DORA metrics, which we called it earlier, like mean time to repair, come down in the frequency and the amount of time, and as important, the mean time to deployment is increased, and the business just loves that. So anyways, just a couple quick slides before we get into Q&A. So who is CEI? We're here today representing our GitHub practice. We have been in the DevOps space for a very, very long time. We actually started in 2004 back with Microsoft, before it was even called DevOps. It was called Application Lifecycle Management. We became very involved back in the early part of the century, quickly got gold certification, and have been on that journey and continued that journey ever since. We are a very notable partner within Microsoft. We are actually in their preferred partner program. There's only 20 of us in the world that qualify for that. When they acquired GitHub back in 2019, they spun up their brand new services and adoption partner program. We were one of the early adopters and helped pioneer in that. We check every single box there is in that partner ecosystem, and we're very proud of that. We have done over 300 engagements to date with our clients, helping them build better, safer, more secure software faster, with great impact on the business. And so why are we good on all that? Why is it such a sweet spot for us? Tim, you want to hit the next slide? Because of the 800 employees who work at CEI, over 600 of them come to work every single day, and they build software themselves, just like our clients do. If you look at the left side of the screen, which we're not going to go through all of that stuff, but those are the different solution practices and solution technology areas in which we have an expertise in. And then we provide services around that. So we provide strategy and advisory that works with our clients, works with the business to answer these questions of how do I solve a business problem or exploit an opportunity? Our technology solutions group, which Siva and I are part of, is actually that build component of actually building out that solution on all different kinds of models and teaming with partners or providing that technology advisory background. Our managed services, that's in the run. If you go plan, build, run in an very simplistic application development framework, that's the group that does do development work, but they're really involved around managing those applications once they're built and deployed. And we support that through Western Europe, Asia, and South America. And our talent solutions and staffing organization provides high quality resources when that's all you need. So with that said, let's open it up to some Q&A.
All right. So here we've got a question. It says, so for orgs that have a large number of GitHub repos already and want to start using Dependabot version updates, is there an easier way than having to create and configure the dependabot.yml file in each and every repo?
This is around Dependabot updates and not around like Dependabot security fixes. Is that correct?
Yeah, so it says if they want to start using Dependabot version updates, is there an easier way than having to create and configure the file? And they say yes, they confirm that that's what they're asking.
Okay. Yeah, we're definitely working on that. You'll see a bunch of like one-click experiences for some of the advanced security features coming along. So we can, I'll find the roadmap item for that, and I can share that after the call. If you know who had asked that, then I can get that over to them.
Okay, perfect. Yeah, I can share that with you.
Thanks.
Thank you. All right. So we'll see. We got time for maybe one or two more questions. So this question for Chris: what are the benefits and measurements of implementing a DevSecOps Center of Excellence, specifically using GitHub Advanced Security?
Well, we touched on some of that before, because ultimately, I mean, we're all IT people on this call, right? But ultimately, we serve the business. And then we go to the basic tenets of what DevSecOps is, and that is speed to market, right? And that's that, do we want to lead or do we want to follow the competition? Really good example of that, who's got this together. If you look back at the pandemic, you ask yourself the question, who pivoted to curbside delivery? Typically, the organizations that did that sooner probably had some good handle on their DevOps processes. I'm not going to make a claim that it's all DevSecOps at that point, but it's about speed to market. It's about optimization of resources, an overused bullet point in PowerPoint. And I talked a lot about people, and I really do like to spend time talking about that and the importance of providing the tool, the process, so they can flourish in their environments. And then about quality and then security comes into place as well, because the costs of breaches and all the rest of it, we all understand those, and they're very, very expensive, and the damage to reputations and so forth. But ultimately, that's in support of what? That's making sure that we're responding to and driving within the business to help them be agile, because that's where we are today, and all enterprises need to be agile. I think Satya Nadella said it very well 5 years ago, that all companies are becoming software companies. DevOps, agility is all part of that. And the pandemic just seemed to accelerate that digital transformation. I gave you a very long answer to a simple question. Basically, my brain was condensing 10 slides down into one statement.
All right. Let's grab one more question here. And then I think we've got one more slide, Chris. So what measures can organizations take to ensure that their deployment secrets remain secure when using GitHub Actions?
Yeah, so the GitHub Actions, so the deployment secrets, that's like more the deployment to the cloud environments, right? Like AWS secret keys or Azure keys. Whenever like we are doing the deployment through the GitHub Actions, the GitHub has like the keyless authentication mechanism. So you don't necessarily to bring the cloud secrets into your GitHub Actions there. You can like basically set up the trust between the GitHub Actions and your cloud environment using the OADC trust mechanism. So that like whenever you are running any actions from that specific repositories, you are setting up the trust already, like okay, any actions that's running from this repository, just assume the particular role, or just assume like these are the permissions that particular token has. So by having those trust, it just like enables the keyless authentication between the action to your cloud providers. That way, like you can skip the secret setup and do this keyless authentication or the keyless mechanism using the OADC from the GitHub Actions. That is like one secure way to do.
All right, great. Okay, so this is the last thing that we want to share with you today. Chris, you want to give the rundown here?
Sure. We love doing workshops. We have been doing, well, I've been in the company since 2010, and we have done hundreds of workshops working with clients and prospective clients. From the old days when I used to have to go to the airport and pick up from FedEx 20 laptops from Microsoft, and we drag them into conference rooms. We don't have to do that anymore. But we love to do workshops about what? To understand your particular scenario, where you are with info application security and security overall within your enterprise, your aspirations or challenges, and then we'll work with you on planning this workshop out. And certainly some of the components around that would be around secret scanning, code security, supply chain security, and the security overview, the single pane of glass, and make it relevant to you. So we'll do some pre-work in making sure that it's relevant and contextual to your organization. One of the cool things we can do is take one of your repositories and run secret scanning against it, see what we find. Let's see what we can reveal from all that. To engage for that, a couple ways you can get a hold of me, and I'm the guy who's going to schedule all that. You've got my phone number at the bottom, which is kind of cut off, and my email address, but you're also going to get a follow-up email from this webinar that's going to have a hot link in it. You can go ahead and just give your name, contact information, and it'll be directed right to me. Love to do it. They're fun, very revealing, and of course we do partner with GitHub on this, so we'll get everybody involved with you and determining what the possible is and what the next steps would be.
Excellent. Okay. Well, hey, thanks again to everyone who was able to join and listen in on the webinar. Thanks again to Chris and Niro and Siva for taking us through the presentation and giving us all the details that we were all looking for. So I think that is it for today. Like Chris said, we'll be sending out a recording, and if you're interested in the workshop, you'll have an opportunity to sign up for that as well. But for at this time, I think we will say goodbye for today. And thanks again so much for joining.
And thank you. And we did learn today that the aliens are in Australia. Okay, so we got that figured out.
All right. Thanks, everyone.
Thank you.
Thanks.
Thank you. Bye.